Hello, Thiago here. So today I'm going to talk about the project that I have been developing in my spare time. So as you can see, I have also upgraded to Easy Platform 3.1. Really cool. Um, so let's see the news. Go here, just default password. So this time I have been trying to work with some machine learning algorithms like SVM, support vector machines, and naive Bayes. So I have checked a project, um, but that project was old, and I needed to do some fixes to make it work in PHP 7.4. I'm going to just show what I have here, and then I'm going to try to explain what I did. So I have this text here, and the idea was that I could build, uh, I could train actually uh, a machine learning algorithm to detect um, important paragraphs. In this case, I want to detect definition paragraphs and highlight those definition paragraphs. And I, I just wanted to start with that and then progress and implement an algorithm that could be able to detect more types of paragraphs. But then I start to think about, let's say, 10 types of paragraphs, and then I quickly realized that it was going to be really difficult to get the data necessary to train each category. So I decided to start with two categories and then progress later after I get some nice results with those two categories. Then I could add a new category. So in this case, I started with definition and the order. So basically, I wanted to highlight important paragraphs. And here is a simple text that I copied from Wikipedia about Canada. And yeah, you can see this is in Wikipedia, the Portuguese version. And then at the end here, I have the buttons that I had in the previous video, plus a few more like superlatives, uncertainty, but I think this is not important in this video. But then I have this one here, this classify paragraphs. So this is a button that when I click, it's going to make an Ajax call to a service that I have implemented here. And the service basically goes and check each sentence and classifies it in definition and the order. And then if the sentence is considered a definition by the um, machine algorithm, then it's going to be highlighted in green. Otherwise, it's going to just display without anything. So let me just click here, and then you can see like it's highlighting some paragraphs, and this algorithm is not perfect. It's actually far from being perfect, but it actually highlights some useful and important information. Um, like for example this here, this is a clear definition paragraph, and then we have some other paragraphs like it's a member of the G7, G20, OTAN, blah blah blah. Yeah, this is kind of important paragraph. So, but it's clear that I need to gather more data and train the algorithm to be better. But I think it's a good starting point what I have right now. Um, so I have all the foundation to to build more um, features in Easy Publish to work with that with this idea. Um, yeah, so now I'm going to show something that I have in the code. So let's see here. So this is what I was talking about. So this project is based in the Kant spheres project. Uh, it does not work out of the box with PHP 7.4, and it even uh, try to use the PHP steamer that we it had a package at some point, but that package does not exist anymore in PHP 7.4. So I need to change that. I need to change a few code. It's not that complicated, but just keep in mind that if somebody is going to try to work with that project, it needs some modification to make it work with PHP 7.4. So this project, it basically um, offers two machine learning classifiers, the naive Bayes, complement naive bias, and the support vector machine, SVM. If you are working with the SVM, you'll need to install the PHP 7.4 package. Not that complicated as well. Um, and yeah, it's going to work. And I needed to build a few classes to make it easier to work in the project, especially in Easy Publish. So I created like a cache module, and then I start to try to work with Easy Publish, Easy Platform content objects as well. Then I simplified again, and I'm just using a file-based cache module, which just works great right now. And then I started to gather to get the data and train this. So basically, right now, what I have is those two files here. This is the definition train data. So as you can see, it contains only 100 sentences or paragraphs. It's actually more like a sentence. It's not even a full paragraph because they are so small that at this point they are like sentences. For example, they have like 20 words, 30 at most. Some of them are like two sentences, so that means it's a paragraph. But anyway, and then I have also this file here. It's the other, so everything that's not a definition I'm putting here. So right now there are only 100 samples, and then I have also a testing file here with 20, and then this other here with 20 as well. So at this point it's really it's just a starting point. So the algorithm is performing uh, about okayish with SVM without steamer. So I'm going to show right now um, a test here. So if I run this test, I oh, just a second. So I performed a test just to have an idea how the algorithm improves according to the number of sample paragraphs. So for example, naive buys with steamer. So if I have 20 samples, this is the accuracy. Then with 40, the same accuracy. Then with 60, it improves a little bit, and then with 80, it improves just a little bit. Then with 100, it actually performed worse. So I think it's more a matter of checking my training data as well. So that's also something that I found that is important to double check the training data. Then I have the naive buys without steamer, and as you can see, it performs. It's worse actually than the naive buys with steamer. So you can see like almost all samples here it performed not that good compared with the steamer one. So for naive buys, the steamer is good to have, at least with this amount of data. Then SVM, you can see that with steamer it increases, then it's capped around 0.8 at this point. Maybe with let's say 1,000, it's going to keep improving. And then without steamer, it's interesting. Like it progresses linearly, in a linear way, and maybe like with 1,000, I think SVM without steamer is going to be the preferred method to classify with a huge amount of data. I think it's going to perform better than all the others. And then I implemented a command to cache the the uh, the the model. So for example, if I go here and so you can see like this is already cached. So all this command is doing is checking the current model. If they are cached, they are. This is just testing, and it's outputting the time that it takes to check out the model and do the test. So it's quite fast. Um, and if the model is not cached, then it's going to create the model, and it takes a bit more. So it's like 2 seconds, 1 second to cache each model. So I think at this point that is it right now. So the basic idea here is that it requires way more data to have something reliable, and it's a really fun project. I think at this seeing the results here, and it's really cool to work with machine learning and see the possibilities. I was thinking about, because I'm I'm also learning um, and seeing the possibilities. I could use this, for example, to check important clauses. Oh, sorry. Important points of a contract, for example, it could be used if you build some data. So if you are checking a contract, you could train your algorithm to detect really important sentence in a contract. I think that's also important as well. and we'll see. Like at this point, the next focus is going to be to create tools in easy platform to make it work a bit better, the workflow of creating data, creating categories, testing the data, and with easy platform and make it improve over time. So I think that is it right now. Bye bye.